Solid, liquid, gas.
Super solid, super fluid.
Or Bose-Einstein condensate.
That one is super cool.
It is plus plasma.
But we haven't even gotten started yet. We truly live in the future.
You ready, T?
Ready.
Scientists have created yet another state of matter.
Woo!
Yay!
It's called a super solid, and while it sounds like a solid,
It's not. A super solid is basically a super fluid that got its crap together.
And by crap, you mean molecules.
I do. The researchers who created the new state of matter took a Bose-Einstein condensate made of sodium gas and used lasers to cool it to near absolute zero.
The atoms are moving extremely slowly. A BEC is a special phase of matter created in 2001, winning researchers the Nobel Prize for Physics.
Once cooled to a BEC, the sodium flowed with zero friction. It's like a super fluid. A superfluid, which is awesome. The BEC was also superconductive, meaning its electrons move through it with zero resistance. There are numerous scientific benefits to these two conditions, but we're not here to talk about that.
In this case, the scientists kept cooling that sodium, and at some point it arranged into a non-crystalline solid.
The scientists called it a superfluid flow with long-range spatial periodicity of a solid.
Those are some fancy science words.
They sure are. Essentially, think of it like a coffee cup filled with a frictionless superconducting gel that if you could stir it, would never stop going around.
Delicious. The fluid didn't suddenly become hard. Instead, it's not exactly solid. Think of it like a gel. It's a fluid, but it behaves like a solid.
They've still got a lot to learn about these fluids/solids, but according to their paper, their supersolid, quote, establishes a system with continuous symmetry-breaking properties, associated collective excitations, and superfluid behavior.
Let's break that down.
That's a lot, yeah.
Superfluid behavior you get, we just explained it, frictionless superconductor.
Collective excitations is a fancy way to say quasi-particles. Quasi-particles are a group of particles that behave as if they're one because their parts are interacting somehow.
And then there's symmetry breaking.
That's also describing particle movement. Normally in quantum mechanics, symmetry is a big deal. Breaking it, a bigger deal.
At the moment, it continues that old saying, the closer you look, the stranger things get.
But come on, do we really have 6 states of matter now? No, we don't. We have way more. The states of matter, solid, liquid, and gas that you've been living with your whole life were never all there were.
It's kind of like when you're learning math. First, you're taught numbers. Then they tell you there are infinitely many numbers. Then, as if they're just messing with you, they tell you there are infinite negative numbers too.
And then you find out there are irrational numbers and imaginary numbers, and you can do calculations with infinities and embedded equations into each other, and yeah, matters like that.
So yes, solid, liquid, gas, and plasma exist, but it's really about molecular arrangement. Solids are interacting heavily, liquids are more loosey-goosey, and gases are just barely interacting, while plasma is free. It can do anything. But on top of those 4, there are several more states of matter.
Cold ones like the Bose-Einstein condensate, and supersolid, and hot ones like electron-degenerate matter, free particles found in white dwarf stars, or the theorized stranger matter, possibly found in neutron stars.
Plus, of course, time crystals, which have low energy states and weird effects across time symmetry.
I mean, we should just do a whole video about states of matter, right?
Yeah, we probably should. Bottom line, we have a new state of matter, yay, but we don't have 6 or 7. We have at least a dozen. They're just more out there, experimental, laboratory only, or extreme kinds of matter.
Our universe? It's pretty awesome.
Boom diada.
Shakalaka. Look everyone, if you want to know more about states of matter, watch this video about time crystals. It'll give you a nice headache, or maybe it already has. Do you have an itch for science to answer? That's why we're here. Tell us in the comments, subscribe for more, and thanks for watching Seeker.
Bye.
Bye.
I'm kind of confused.
You're kind of confused.
So I only can hear like the sound at 60 FPS while the other one's like, yeah.
Oh, you couldn't hear it super well?
The sound is fine, but the video's laggy.
Yeah.
Yeah, videos don't tend to work super well on here. But maybe you saw a little bit of what they were saying. So did anyone catch what they were talking about?
Dwarf star? Something like a dwarf star or something?
Yeah, well, a lot of the stars, well, they could have parts of this, right? So basically what they're saying is that there is like this new state of matter that we can't really just have like right in front of us, right? It has to be under certain conditions. So we think about the 3 states of matter as solid, liquid, gas, right? But there's others that maybe aren't so common to us. one that's really common is plasma. Does anyone know what plasma is? I was counting on Gr7 to know what plasma was. It seems like a random piece of knowledge he would know.
Oh, the fourth state of matter.
Mm-hmm. Well, yeah, so in plasma, particles are moving a lot faster than in gas. And even like the electrons, the parts of the molecule might be split up. And then what they were talking about, this super solid, the particles had way less energy, right? So I'm going to show you guys a little visual of the states of matter really quick. So you can find this online if you do the states of matter simulator. It's through PHET, P-H-E-T labs, if you want to look this up. But basically you can look at these particles and see how they're moving. So right now we've got neon in here, the neon atoms, and if this were at negative 259 degrees Celsius, this is what it would look like. Let's look at it as a gas, negative 217 degrees Celsius. So the hotter you make it, you can see the movement of the particles, they start moving a lot faster. The colder you make it, the particles start to slow down. So as you can see, the temperature getting lower, the particles get slower. So they're still a gas right now. They're still kind of filling the space of their container, but you can see them starting to come down to the bottom a bit, starting to be more liquid-like, right? So liquid, they still fill the shape of the bottom of their container, right? But they won't go all the way up to the top. Their attractions are a bit more strong. They're still kind of moving. Whereas if you go to a solid, they pretty much keep their own shape here, right? But what you'll notice is they didn't stop moving, right? They're still moving. They're just kind of vibrating in place. There's another part of the simulator here where you can control pressure, which, as you can see, if I add pressure to this, it doesn't really change shape either. Whereas if this were to be a gas, the pressure would change how close all the particles are to each other, right? So we call that compressible. Gas, we can compress, we can squish it together. A solid, maybe a tiny bit of compression, but not really much at all. A liquid, not much compression either, maybe a little more than a solid. But that's kind of the basics of the states of matter. And again, there's many more, like that video we watched at the beginning. But we'll be talking about these three in more detail. So yeah, that's kind of our work for the week, what you guys are going to be doing. So how that's going to look is you will watch some videos on Edpuzzle, and you are also going to do some labs. So the labs will be things you hopefully have in your own house. And I gave you like a few different options, I think 4 different options, and you just have to choose 2. So look at those, pick the ones you can do, and at the end of the week you'll have some workbooks as well. So I put that all out for you on ManageBack. You should be able to see that. I can share that with you really quick if you want to see it here. There you go. If you're confused about today, when I say the states of matter table, I'm going to give that to you in a minute to try. Tatiara, you have a question?
When I click the link for the calendar, it shows the calendar for last week.
Oh, it does. Okay, thanks for letting me know. I will fix that for you guys. But yeah, here it is for now so you can see it. And then the description is still right, correct, Tatiara? Like this? Well, I will fix that on ManageBack for you guys. But here's this for now. So what I want you all to do is I asked you if you could bring something to write with and to write on. So I am going to screen share this PowerPoint right here. All right, so I got this table. I want to see if you can write this out on whatever you brought to draw with and then fill it in. So I'm going to give you guys like a few minutes to do that. When you get it done, just go ahead and hold it up to the camera so I can see that you have done it. Okay, let's see if we can get some people to fill these in. How about, let's see if Jose is here now. Jose, you know the first one here, the distance between particles of a solid? All right, I don't hear Jose. Mark, you want to answer this one for us?
What?
The distance between particles in a solid.
There's none, right? Is there?
Maybe a tiny bit, but not much, right? A lot
Okay.
of them are touching. Yep, good. All right. What about in a liquid? Let's go with Francisco.
Yeah,
What would the distance between particles in a liquid be?
a lot more. I mean, just a lot. But it's more, just more.
A little more than a solid, right? So not super far, but more than with solid. Good. And then what about with a gas? Let's go with Valerie.
Far apart.
Yep, pretty far apart. Good. Okay, and then the next part here. Sorry, it's hard to see you guys and look at my screen at the same time. Okay, the next one, movements of particles in the solid. Gerard. There, Gerard? All right. How about Dylan? Movement of particles in a solid.
They move together.
And they're kind of moving, like vibrating, right? Moving in the one place. Good. Movement of particles in a liquid. Jessica.
It's more like they can move.
Yep, they can move more than from just vibrating, right? They can actually move around a little bit. And then in the gas, the movement of the particles. And let's go with gallium.
H.
Can you say that again? The movement of particles.
H. I didn't hear your question. What do you say?
Can you describe the movement of particles in a gas?
Gas, fly, big space, yes.
There's a big space, so they must be moving pretty fast, right? Awesome. Okay, so I'm going to fill in the rest for you guys here for sake of time. So these are the ones that we already did together. These ones you guys can fill in if you didn't get them correct before when you're writing them out. And then we've got, so it's very strong force between the particles in the solid. In a liquid, and when I say force, what I mean is like they're kind of attracted to each other, almost like a magnet in a way, not quite, but you can imagine it like that. They're being pulled towards each other. It's actually because of their electrons. So in a solid, it's very strong. In a liquid, it's not quite as strong. And in a gas, there's almost no, like, there's nothing much pulling them together. They kind of just are doing their own thing. And then as far as the shape, solid is fixed shape, liquid is the shape of the container, and the gas can actually fill the container, fills the whole space. So yeah, hopefully that is a little bit of review for you guys, but maybe a few of those were new for you or worded differently for you. So are there any questions about that? I see something in the chat. Let me check that really quick. Yes, this is for science today. So basically what you have to do is you are copying this table. So if you show me on your screen, then you are done with that. That's all you have to do. If you didn't show me on your screen, or if you weren't here at the meeting today, that should be 4 people, you gotta email it to me. So if you can show that to me on your screen, I know you did it, then we can do our riddle and pray, and you guys will be good to go. So show them up there. I see Brian, Keegan, Mark, Mary, Tatiara, Kimberly, Jessica. Good. I see Moses, Gerard. Awesome. I see Jaden's there. And I'm recording all this, by the way, so I can look back and remember, make sure I don't forget. I see Moses, Eileen, Tatiara. Yep, if I said your name already, you can put yours down. Thank you. Sweet. Good. All right. If you did not show yours, then make sure you send that, like, take a picture of that piece of paper, send it to me in an email by the end of the week. But that's pretty much your work for today. But you can get started with the next day's work if you want, because Wednesday there will be those labs where you actually need some things. Like I said, most of it stuff you should have, like ice, water, salt, things like that. But take a look at those. And that's pretty much what I have for you guys. But